way we heat our homes and buildings is changing. In this video series, we will take you through the new technologies and the future of heat.
Great to see you.
Hi, Mike. Bill Hewa, Product Manager for Stone Mountain Technologies. How are you?
Very good. Appreciate you coming out and showing us some new technology. So obviously, I've seen this technology. You and I have had an opportunity to talk about it. For people that don't know what this technology is, just sort of explain where are we, why are we here, and what are we looking at today?
Well, what you're looking at is the ANESI air handling unit that goes with our 80,000 BTU gas heat pump, which we'll go look at in a moment upstairs. This is the indoor air handler. This is a hydronic air handler. So it takes the 140 degree hydronic fluid coming from outside and brings it into this, and it handles both your space heating, forced air space heating through an A coil, as well as your domestic hot water. That domestic hot water is an option for the customer. So they put this in, this replaces the furnace. Similar footprint as to the furnace. Bring the hydronic fluid in, circulates through the coil. You hook it up to the existing distribution system for the house, and you're able to take advantage of our highly efficient gas heat pump technology, which is 140% annual fuel utilization efficiency. And this takes place with the furnace.
So what I like about it is this quite literally, because we actually saw the furnace that was here, this is literally the same footprint. So from the standpoint of retrofitting it, you might have to make a small plenum adapter, but taking out that old gas furnace or electric furnace, whatever happens to be there, removing that and sliding in the new appliance appears to be pretty simple.
Very simple. You're absolutely right. And the nice thing is about this product is, first of all, it's low power consumption, so there's not going to be any expensive upgrades to the homeowner's panel. It's 115 service, 14.3 amps, so a 20 amp circuit will suffice to powering this. And like you said, you adapt it to the existing ducting system and you're off to the races.
So this package air handler return, so in this particular case it's a right hand return. Is this a universal air handler where I could do right, left, bottom discharge?
You can do right, left, and bottom. This is an upflow only. We will have future products out that include downflow as well as horizontal configurations, but this is our initial product launched into the market.
Now, we know this. The outdoor unit here is an 80,000 BTU. Is it modulating or is it a fixed 80,000 BTUs?
It's a fully modulating unit. It's 4-to-1 modulation. This unit has a modulating blower in it, and there's a lot of actually additional functionality in this air handler that makes it much, much nicer and much more easy for the contractor to install than a typical air handler. So for example, in typical hydronic systems, you'd have a hydronic board on the wall, you'd have a glycol reserve tank, you'd have a three-way switch to partition the water, the hydronic fluid between your space heating and your domestic hot water needs. All of that is built into this unit. So not only do we have a standard blower and an A coil in this unit, but we've got a glycol reserve tank and a feeder tank. So the contractor, it's very easy for them to fill the hydronic loop from this unit. They just fill the tank, take the cap off, fill the tank, bump the pump a bit. By the way, there is a circulator built in, so there's nothing that they have to go to the hardware store or the supplier to pick that up. There's also a three-way valve. So it partitions the heat between the space heating and the domestic hot water automatically.
And so what circulator is built into this unit?
I think this unit is a Bell & Gossett PL55.
Okay, so that's a pretty reasonably sized circulator. So from going from the outdoor unit to the indoor unit, we shouldn't really run into issues from the standpoint of being overcoming the pressure.
No, you shouldn't. We've sized that to hit most typical loops. Contractors will need to be cognizant of the length of the lines, the number of elbows, make sure that that's going to fit within the profile. If they go outside of that profile, they can certainly add additional circulator capacity to this system.
The reason I like to ask that question is they've piped this in PEX, and obviously no issue at all running PEX piping to an air handler. But in many cases, if you specified 1-inch copper, usually you're saying you need 1-inch piping, which is a common thing for manufacturers, and as installers we have to recognize that PEX and copper do not have the same ID, and that's why I'm asking what pump is in it. It's good to plan, and it sounds like you guys have with a circulator that can overcome anything that they might pipe it in, whether it's PEX or copper or whatever the case may be.
Absolutely, absolutely. Let me remark too, real quickly, this could be 1-inch copper. If it's PEX, we want it to be oxygen barrier PEX. It needs to be oxygen barrier so that we preserve the integrity of the hydronic.
Yeah, so you probably noticed before we started filming, I pulled the insulation off. That's exactly what I was looking to see. I wanted to see if it's an O2 barrier, because obviously without the O2 barrier, you know, your air handler might be okay, but all the other components connected to it, like the circulator, they're going to have a problem with that. We're going to see premature failure. So it's a pretty simple system, and I like that. If you're going to have something that's an emerging technology, which is certainly what I would call a gas absorption heat pump, I think that the way you can make people comfortable with it is give them a packaged unit that has everything built into it, so they don't have to worry about, well, I don't understand how to do this or how to do that. This is quite literally hook your water connections up, drop the supply, drop the return, wire it, and you're done, correct?
Absolutely. And you know what we're trying to do is make this easy for the contractors to embrace, but the homeowners as well.
Gotcha.
Okay? We are talking about a gas heat pump that's located outdoors, so you're keeping all of your combustion, all of your refrigerant outdoors. The only thing brought in is the 40% propylene glycol food grade hydronic solution. It's got an inhibitor in it, basically for the benefit of the gas heat pump outdoors. So it's very, very safe.
Right.
Okay.
Now, are you guys supplying the propylene glycol, or are they getting that from their own source?
We will be supplying propylene glycol to the reps, and the reps will supply it out to the contractors.
Okay. So the way this unit is connected up right now, so we've got the two connections on the one side, two connections on the other side. Just sort of talk us through what the connections are.
Okay, so you've got two connections, a supply and a return from the gas heat pump. That's bringing in your 140 degree typical, 140 degree fluid. Comes in, it goes through the coil for space heating applications, and then if there's no domestic hot water, like I said up front, that's an option for the homeowner. If they don't have that domestic hot water option, it's going to return back to the gas heat pump for reheating. If the customer so chooses to have that domestic hot water, and that's an 80-gallon indirect storage tank, we're utilizing a tank actually. Love this tank. It's lightweight, it doesn't need an anode, it's got a polymer tank and a plastic jacket, so it's very, very light. If they do choose that option, then you're going to activate these other two ports. One of them is supply that's going to go to that indirect storage tank. It's got a 20-foot copper coil inside of it, and the other is the return pipe. So once it heats up that water, it's going to return back and go back to the gas heat pump for reheating. And all that is done automatically. Okay, we've got control algorithms that are going to partition the heat between the space heating needs and the domestic hot water.
Right. One of the things I see very commonly, because you know I'm a technical trainer, I see a lot of this equipment, is they'll drop in the appliance, they don't have that integrated inside of the unit, and then the contractor is faced with, okay, I have to design my own opt-out configuration so I can transition from heating to domestic hot water. And then depending on how skilled you're at that, you can get a phone call 2 days after you install and go, I don't have enough hot water. They can end up blaming the equipment, but you come out and go, well, it's not quite piped right. We would have piped it differently. In this application, as you say, it's two pipes going from the outdoor unit, two pipes going to your domestic hot water, whether it's your tank or somebody else's.
Correct.
And it works great.
Yeah.
What kind of a delta T does this piece of equipment work on going out to the outdoor unit into the indoor unit?
It needs a 20-degree delta T to really optimally operate at peak efficiency.
Okay, and what would the range be? So if 20 degrees is your max efficiency, what would be your minimum, what would be your maximum this equipment could run at?
Our maximum that we can supply to is about 150. We prefer to operate in the 140 range.
Sure.
So coming back, I think our minimum coming back is in the 112 range. So it's going to depend on what the heating needs are, what time of year it is. We've got an ambient reset curve that is part of the control algorithm. So as the temperature gets cooler outside, it's going to provide more heat to the space heating.
Okay, so when we look at that, would I be able to run this unit on a 30 to 35 degree delta T, or at that point am I going to start to run into issues with the fence on the outdoor unit?
No, you'd really want to be at much closer to our desired 20 degree delta T.
Okay, so with a 20 degree delta T, you guys feel comfortable that the installers could use a traditional indirect? They're not going to need an indirect with a larger coil surface area, 20 degrees at 140, you're
what we
comfortable with that?
prefer to do, if they don't choose to use the indirect storage tank that we've spec'd out with our system, is that they contact Stone Mountain Technologies, talk to our technical support, and make sure they've got a tank that will work.
Yeah, I think one of the important things, and it doesn't really come into play here, but we'll say it since we're talking about it, one of the things we see happen commonly is people will take a heat pump technology and they'll apply a traditional indirect on it, which is where you're going with this. Traditional indirects do not have a lot of surface area inside of them, so you don't get great heat transfer. On a heat pump, at least an electric heat pump, we want to have an indirect that's got a very large surface area on the coil. It sounds like you're saying something similar with yours, like please don't go and buy any old indirect off the wall.
Yeah, I'm saying actually the exact same thing.
Okay.
Like I said before, we prefer to have the indirect tank that we've spec'd out. It's got a 20-degree copper coil. Now, you don't have to use our tank, and you don't even have to use an indirect storage tank. We could use a standard storage tank with a plate heat exchanger.
Yeah.
So if the application requires something outside of the amount of heat exchange space on the coil, we can certainly look at an external plate heat exchanger to accomplish that.
Yeah, I think that one of the things also to look at on this technology is you have to ask yourself, why are you not using the indirect that was designed specifically for the equipment?
Sure.
Like you as a contractor, do you want to be the engineer responsible for the job? I know I wouldn't want to be, right? It's nice to be able to use the technology that's designed. And I think it is important as we look at new heat pumps that people understand that I have a saying I use a lot, we talked about it last night, heat pumps are not boilers. You know, and we certainly can't apply them the same, but in the same token, I'm not saying that you can't replace a boiler or a furnace with a heat pump. As you know, I replaced my gas furnace with a heat pump in my house, and it works great. You just have to understand the limitations.
Well, and that's just a whole other set of applications. Our heat pump will do a whole host of applications. It'll do the hydronic applications to replace or augment boilers for residential or commercial applications. We can do pool heating. We can do ice and snow melt. We can do light commercial. So we're ready to attack the market with this solution.
So indoor unit communicates to the outdoor unit?
Absolutely.
And it's a communication signal between the two?
There's a Modbus between the two.
Okay.
Okay, in this unit, this is a field trial unit, so we've got a slightly different architecture.
Yep.
In the production version, the Modbus will communicate from this air handler out to the gas heat pump, and then we have a full-time cellular connection on the gas heat pump.
Saw that, yeah.
That's going to allow us to monitor the units 24/7, make sure they're operating flawlessly.
Yeah, so when I did my snoop before the camera turned on, I did see all of that. So you guys are able to monitor this piece of equipment. It's part of a field trial is the word that I'm going to use for it. You're able to monitor this equipment, see what the performance is anywhere in the world, and that's a really nice function to have.
It's great for the field trial, Mike, but the other thing is we're going to have that monitoring on the production units as well.
Yeah.
So we've monitored these field trial units specifically to be able to react to how consumers use them, how the contractors have installed them, what the needs are. And by the way, we've got the ability to flash software at any given time to the unit if we need to make some type of an upgrade. You could even change the personality of the unit as well.
Yeah.
Okay? But that cellular communication out in the gas heat pump is the key to it. We're going to be able to monitor every single unit that we install, or that the contractors install, and we'll know how they're performing. We'll know proactively in advance if there's any service issue that needs to be addressed.
So that's service diagnostics. Is that coming built into the unit, and then they would just pay like a small fee to have the cellular access, or is the plan to move beyond cellular? They just put it on their Wi-Fi, and that's a baked-in function for the contractor?
That's a great question, but you know, we can't go Wi-Fi. That's what this is, Wi-Fi, and we found that Wi-Fi is too unreliable.
Right.
What it is, it's a full-time cellular. We're not charging the customer anything. We've baked that into our price to the contractor. That'll be full-time connecting with us through that cellular link. Cellular technology has really improved in the last several years, so monitoring has become actually very, very much cost-effective.
Yeah, so that is ingenious, because I can tell you that we have technology that I've seen. There's one particular unit that I'm not going to name. It logs 152 data points every 10 seconds. But the problem is, the assumption is that the installer or the homeowner is allowing you to connect that to their Wi-Fi. In your case, it's not dependent on the contractor, it's not dependent on the homeowner. You get all that diagnosis access because you've built it in, you've built the cost in. There's no premium to the contractor to, I can't say do the job right, which isn't really fair, but to get the access to the data that makes this equipment work much better. Yeah,
you know, with the field trial, we've got a good relationship with these customers, and it's ongoing for several months. So working across their Wi-Fi seemed to be an easy, quick solution. The long-term cellular is going to work out much better for us. The other thing that I'd like to mention too, in terms of the contractor and the homeowner having the capability of seeing what's going on with the unit, is when the product launches here in the next few weeks, we're going to have an app that the homeowner and the contractor will have access to. So from their handheld device, they're going to be able to see what the unit is doing, how it's performing. Now the contractor will have a separate login. He'll have much higher access to available information than the homeowner will. But still, it's a way for the homeowner to connect with the unit and see what's going on.
Great. Well, this is a great walkthrough. I think we should head outside and look at the exciting part. Not that this isn't exciting, but go look at the outdoor unit and get our hands on it.
Sounds good.
Awesome. So, this is the outdoor unit.
Absolutely.
Talk to us a little bit about this outdoor unit. What are we looking at?
This is the Stone Mountain Technologies ANESI 80,000 BTU gas heat pump. Runs on natural gas or LP or 20% blends.
So when you're talking about running on a 20% blend, what is the thought process to that for people that don't understand?
It'll run on 20% blend of renewable natural gas and hydrogen blends. There's a few gas utilities that are actually looking at hydrogen already. So we've been working with them to field trial the unit.
So it sounds like what you've got is you've got a gas absorption heat pump that you guys are sort of looking beyond right now. Like right now it's running off natural gas, it's running off LP, but down the road you're looking at, you want to be able to use this technology to use whatever they're putting through those gas lines 5 years, 6 years from now in collaboration with various gas utilities.
Absolutely, that's what we want to do. This unit is 140% annual fuel utilization efficiency. So that efficiency means homeowners are going to save anywhere from 30 to 50% on their gas use. Now when you're using standard natural gas, then you're obviously decarbonizing in about that same amount. But when you put a renewable or a blend in this, then you're able to actually accelerate the effectiveness of decarbonizing.
Right. So where you're going with that is by using a gas absorption heat pump. It's you're still using gas, but we're naturally reducing that carbon because we're actually using less gas than if I just had a gas furnace or a gas boiler in my home.
Absolutely. And the key thing to think of about this product is it's going to provide the homeowner the same comfort level at a lower gas use, and they're saving the planet at the same time. They're decarbonizing. The refrigerant in this unit has zero global warming potential, so they can rest easy. It's not something that's going to be replaced by a federal mandate in the next couple of years. It's not anything that's going to be particularly harmful, and the fact that it's all outdoors makes it a really safe unit. You've got all your combustion outdoors, you've got all of your refrigerant outdoors. When this comes in and replaces an indoor furnace, you can seal back the openings for the flue from that furnace. If they take the optional domestic hot water storage tank at the same time, they can take out their atmospheric or their power vented gas water heater and seal up those connections as well. So the only thing you're bringing into the house with this unit is 2 1-inch pipes, PEX, oxygen barrier PEX, or copper, and that 140-degree hydronic fluid is what's accomplishing the heat exchange inside in the air handler as well as the indirect storage tank.
Right. I think you touched on a key point we want to mention. This is a monoblock design, which is really, really important. If you look at the trade shortage that we're having, the more trades we need to be involved, it can make these jobs slow down a little bit, right? So the reality is you're dropping a package unit outside, you're simply running a water and glycol solution inside. It takes some of the fear of new technology away because we all know how to do that, right? Like running, copper or PEX or whatever material you choose is a pretty simple process to do.
Right, it is. And there are going to be a few extra trades involved, and we've had some situations where contractors have served as a prime and then they've had additional contractor help. But it's our hope that through an extensive training program, we'll get the contractors up to speed so they're comfortable doing every aspect of the installation system.
Yeah, from a wiring and gas and piping standpoint, what I would say to you is this doesn't look any different than anything else I've ever seen. Really what it comes down to, which is a good thing, really what it comes down to is you just have to educate them on the inside of the box and what's different in that box and how to do a startup on this piece of equipment, because I would imagine there's some differences in starting this up versus starting up a gas boiler.
There are. We've got an extensive set of technical literature to help. We've got a 4-page commissioning checklist to go along with our extensive training curriculum. But when the contractor brings this out, you're right. He's gonna need 115 volt, 7 amp of power. Typically, depending upon the length, a 1/2-inch gas line. So there's no upgrade there. Shouldn't be any upgrade then to your electrical or your gas. He's gonna plumb out the hydronic lines, get it all connected, and then fire it up. And by the way, we have one SKU that's capable of handling the variety of different fuels. It's going to be able to handle natural, LP, at altitude, and basically they're going to be able to dial in the combustion via the gas valve. So there's no additional SKUs, no hardware change to accomplish that.
So if I want to convert this from natural gas to LP, I don't have to put an orifice in, I don't have to change the gas valve, I'm just adjusting the existing gas valve.
There is no hardware whatsoever required. All you do is adjust the combustion.
No, that's very cool. I wouldn't have known that. So this obviously is a gas absorption heat pump, so where's the compressor?
Okay, so, it's a thermal compressor.
Oh, right.
Okay.
So as we look at this unit, so it's a gas absorption heat pump. You knew I had to do that.
I know.
So it's an ammonia-based system then?
It's an ammonia water solution. It's 11 pounds of ammonia, 9 pounds of water. Okay, what happens is, this is the desorber, and this is all insulated so that we get optimal performance, okay?
Yep.
But normally if we were in a lab, I'd let you take a closer look. Your burner's gonna fire on. It's gonna heat up that ammonia water solution, okay? Up here in the rectifier section of it, It's going to separate out that ammonia. Ammonia and water have a tight bond, but that heat is going to separate the two, and then that purified ammonia is going to route through to a condenser, okay, where it gives off heat. The liquid is going to drop into a storage tank down there on the lower left side, and then it's going to go through an expansion valve and come through the evaporator coil. So for every BTU of fuel we're burning, natural, LP, whatever, for every BTU, when we come out here through the evaporator, we're going to capture about another half a BTU from the ambient air.
Gotcha.
Okay? That's going to come back in, and it's going to recombine with the water in the absorber column, and that's a very exothermic reaction, so you get additional heat from that. We've got a multitude of heat exchangers in this, and what that does is that brings your coefficient of performance up to a 1.43. That's how we get the 140% AFUE. And that is all those steps in those heat exchangers are heating the hydronic fluid, which then goes into the house.
So the heat exchanger design itself, obviously we can't see it. We're going to take the whole unit apart. Maybe we'll go to your facility and do exactly that. We'll take a whole unit apart.
Sure.
The heat exchanger design, is there some features in that design from a safety standpoint? Like, does it need to be a double wall heat exchanger? Like, how do you guys design that heat exchanger?
Well, the heat exchangers out here are all designed with carbon steel. Okay, they have to be compatible with the ammonia as a refrigerant. We have a variety of different safety measures built into the unit. We've got a pressure relief valve. We've got a temperature cutoff here in the desorber, because that's where the heating mostly occurs.
Right.
Okay, so if you get to a certain point in the temperature, it's going to cut off. Your pressure relief or your pressure cutoff is up here in the top of the unit. We've also got a pressure relief valve, so if it were happen to get to a point where multiple safety factors haven't kicked in, it's going to vent. Now, if that were to happen, and that's very low likelihood because it would take multiple failures of components, you're outdoors.
Yeah.
It's ammonia.
Yeah.
Ammonia is very much a safe refrigerant. In addition to having zero global warming potential, very, very difficult to ignite, unlike other heat pumps. And
like an R290 or something, for example.
Very much unlike those. It's also non-toxic. I mean, no one likes the smell of it. It burns your eyes, but that's at a 5 part per million level. Don't know exactly what the Canadian regulations are, but from a U.S. perspective, OSHA acceptable level of exposure is 25 parts per million for 8 hours.
Right.
No one's going to stand next to it for more than a couple minutes. Now, if that ammonia were to come out, it's completely safe. It's going to dissipate. It's lighter than air. It's going to rise in the atmosphere, break down, and in 2 days it's going to be fertilizing something.
Right. So from the standpoint of the safeties in this unit, it sounds very similar to an electric heat pump. As you know, I am an electric heat pump guy. I also deal with some gas stuff. So basically, if this unit ever gets itself in a condition where we're not rejecting heat, we start to superheat the system, it's just going to lock itself out on high pressure, just like a 410 or a 454 system might do.
It's going to cut off and lock out,
right.
Okay, and then at some point it will try to restart itself. But let me draw an important distinction between this and an electric heat pump. With an electric heat pump, you take it out to the home, and then you have a line set. So you've got to put refrigerant in it to get that line set into the house. You're taking that refrigerant, which is potentially toxic, potentially flammable, into the house. With this, our product, the ANESI gas heat pump, it's a completely sealed system. It only remains out here. There is no refrigerant going indoors. All the combustion is out here. So you're only, again, taking that hydronic fluid into the home.
Okay. So looking at this unit from the flowing of water going from the outdoor unit to the indoor unit at 80,000 BTUs, I'd expect 7 to 9 gallons a minute. Is this kind of the same? There's no special flow rules involved here?
No, there's some special flow rules, but you pretty much nailed it.
Okay.
Okay. So if you're at 8.5 GPM, you're in good shape.
Yeah.
Like we talked about on the air handler, the contractor has to be cognizant of how much loop they've put in the hydronic line, where the bends are.
Yeah. What type of material you're using? Understand ID versus OD. Yeah. Common sense stuff.
Even ball valves. We built in ball valves into the back of this. This unit ships with some hydronic fluid actually in it.
Okay.
To reduce corrosion. But those ball valves are there to keep it secured while it's in shipment, and then when the contractor's got the hydronic lube hooked up and purged, he can open those valves and he's good to go.
That's interesting. So it actually comes charged with the fluid from the factory.
It has the hydronic fluid just in this part of the system.
I can't say I've ever seen that. That is very interesting. So this unit's very quiet. Now we have to be careful in saying that. Some people watching, what do you mean? I can hear it running. We have all the panels off. Like all the insulated panels are off of
Absolutely.
it right now. With the exception of we can obviously hear it running because the doors are off. It's very quiet. Like I thought it was gonna be louder, to be totally honest with you, right? Is there anything you guys have put into this design to try to keep the noise level down comparable to an electric heat pump?
Well, we've designed some of the piping around the solution pump to mitigate any kind of sound issues. We've designed the air handling indoors to mitigate sound issues. But a couple things you need to know about this is, first of all, like I said before, it's 4-to-1 modulated. So when it's out running at 25%, it's even more quiet than this.
Yeah.
Okay. The other thing is, there's a mindset change. Somebody coming in to replace a furnace, they're not used to this type of sound outdoors, especially if they live up north and they don't have any air conditioning.
Right.
I realize that proportion of the demographic is becoming smaller.
You'd be surprised how big that demographic still is.
But nonetheless,
Yeah.
that sound is something they'll have to get used to. You know, I live down in the south of the United States.
Yeah.
There, I've got 2 heat pumps on my house. I'm used to the sound.
Yeah.
If it's something new, contractor needs to qualify the customer so they know what to expect up front.
Well, if we look at where this was installed, and that's one of the things I always like to look at, if somebody calls and says, hey, this piece of equipment got put in too loud, come look at it. And I legit went to a house where somebody was complaining that the piece of equipment was too loud. I walked into their living room and the heat pump was in the middle of their living room. I'm not making this up. And I was just like, I don't know what to say right now. I need to go back to my car and politic a polite answer to WT, right?
Yeah.
Like, what is going on here?
Right.
So you always want to install a piece of equipment wherever it's quiet. I'll just give an example. In my own house, I have a carrier unit, and there's nothing wrong with my carrier unit, but it is as loud as this, right? So it's not, we just happen to be here standing with high definition microphones. I don't want people thinking this is a loud unit.
Right, no, absolutely
I'm impressed
not.
how quiet it is.
Absolutely not. We are well below 60 dBA, which is the threshold that you have for a lot of the electric heat pump products.
So as far as installation goes, really you're going to install it just like you would any kind of heat pump. Don't put it next to their deck. Don't put it next to their bedroom door. The noise we're hearing right now, what is that noise that we're hearing as the unit is running?
So you've got a couple things. You've got a solution pump, which is making sure that ammonia water solution gets circulated every time that the ammonia gas comes back in and recombines, that solution then gets circulated back into the desorber,
Right.
so it can be reheated and go through the process. The other sound that you're hearing is the sound
Yeah, I'm definitely not
of
even hearing that.
of the evaporator
Yeah.
fan motor, and that one is very, very quiet.
Yeah, if you can hear the evaporator fan, I can't. Like, it's very quiet.
Yeah, we've gone to extreme design engineering measures to design the venturi and the coil, the fan itself, even the stand. There's a support under it
Yeah.
to keep it all very secure, so there's no vibration and so that the sound is all mitigated.
Would this have any kind of a defrost cycle? Does it have any requirements to be raised up off of the ground, just from the standpoint of, you know, any kind of moisture it's going to freeze up?
2 good questions. First of all, it does have a defrost cycle. So if it ices up, there is a 6-minute hot gas defrost cycle, but it can continue to provide heat to the home
Oh, very cool.
in that situation. So it doesn't have to shut down home heating. It can still provide the hydronic fluid. Now, with respect to snow, there's a couple things you need to realize. First of all, our air intake for the combustion system is right over here.
Yeah, so you'd be pretty
Okay.
hard to cover that in snow. It's the top of the unit,
It's
not the
41
bottom.
inches. There's
Yeah.
a box in here, so that height is 41 inches. Now,
Gotcha.
if you're in an area that's going to routinely have a foot of snow on the ground, probably would be best to raise it up. The real requirements in terms of placement are that it has to be stable and it has to be level. Like I mentioned earlier, this rectifier is what makes sure the ammonia gas is purified so it can go through the evaporator cycle.
Right.
You get it level, that thing's going to work really well. But you can raise it up, you can use unistrut, you can put it on pavers. I mean, it can go on a concrete pad.
Yeah.
This is certainly fine, though.
Yeah. And so how much would this unit weigh roughly?
About 550 pounds.
About 550 pounds. Okay, so I mean, it's a heavy unit, but that's not surprising. I would say to you that most heat pumps are heavy units. There's not a
Yes.
lot of them that are very light.
Yes.
My own heat pump, I didn't lift it up onto the side of the house by myself.
Right.
It required a little bit of help. So one of the other things I'm a little bit curious about is there's a little bit of no-nos, and I'm curious how they apply here. And I don't think they do. This isn't a compressor bearing unit. So normally, if I saw PEX connections coming out to an air-to-water heat pump, I would have some serious concerns. If
Okay.
you ever had that compressor fail, which again, you don't have, I made the joke, but I want to be clear, there's no compressor.
Right.
Right, so if the compressor failed, that water could flash to steam and it could actually burst the PEX. That's not going to be an issue for you guys here. There's no scenario where
No.
your pump fails and suddenly you're flashing to a temperature where you then get to steam.
No, our safety mechanism is always going to ensure that if this desorber hits a high point in temperature,
Yeah.
it's going to shut itself down.
So on top of that note, the other things that we typically like to see on air to water heat pumps is we would like to see some sort of a braided connection from the actual penetrations going through the wall to the outdoor unit. But again, the reason we ask for that is because it's a compressor bearing unit. We don't want that noise transmitting through the copper into the actual building itself. In this case, because it's not a compressor bearing unit, from your experience, you're not getting any of those noise transmission issues.
You shouldn't, but let me make one note here.
Yeah.
It's all covered up here, so you can't tell. But we do recommend to contractors that they put an 18 or 24-inch section of a flex line here.
Gotcha.
Just in case, if they've excavated the ground and the ground settles a little bit, if they're in a seismic area,
Yep.
they want to make sure that that's not going to be a connection that breaks over the long term. Now, you want to make sure the thing is nice and stable. And by the way, if you're in a seismic area, these fork pockets that are built into all four sides, great way to strap it down.
Yeah, that's a good point.
You could even do unistrut and then strap it to that.
Yeah, so I think then we agree it's good practice, and they've done it here. We just can't see it, to use that braided hose connection.
I'll hope it's under there somewhere.
Yeah, and I'm sure it is. It's all insulated. We can't see it. The other thing, not so much with this unit, but with heat pumps in general, if you're going to be running any kind of a PEX connection to it, it's just little things like your neighbor bangs into it with a riding lawnmower. Having that flexible connection is a good protection from any nuisance issues that you might run into.
It's a great protection, and in our installation training, we offer contractors two options. They can either run the lines in a secure fashion above ground. Obviously, they want to insulate them. You're going to penetrate the house in some reasonable manner. AirX happens to be one of the devices that we use, but it can also be buried as well. So you can go through the house, through the penetration into the house below grade, as long as you've got it well secured, watertight, and well insulated.
Yeah, and I think the takeaway I should add, just so we don't put any fear into people, this is a water line connection.
Yeah.
Right, even if we bump into this, we're just losing water and glycol. It's very easy to recharge, it's not very expensive. You know, if this was my Carrier AC unit and I decided to drive into it and break off the line set, that's not going to be a cheap repair, right? This is a pretty easy repair.
Yeah, it'd be an easy repair, and I will tell you this. We obviously want the lines to be well protected and secured. If somebody does happen to bump into one and you spring a minor leak, the air handler downstairs has a reserve tank that's going to continue to make up that volume until it gets to a point where it's got to be fixed. Then you're going to get an air signal that's going to shut down, and the contractor will know. But by the time that happens, between the contractor monitoring it and our monitoring it, we'll have a pretty good idea what's going on.
Well, the reality is, as soon as they hit this line, we're going to be in a situation where we're no longer moving fluid. The unit is going to see a high temperature event. It's going to lock itself out on high pressure anyways. It'll protect everything. The homeowner will get an alert. They'll call. The contractor will come out and they'll fix it.
Yeah.
So, well, that's great. I appreciate you giving us a tour to the outdoor unit and making the time today.
My pleasure, Mike.
Thank you, my friend.
Thank you.